have a good view. Okay.
Correct. Yes.
So I don't have to give too much money.
Yes.
Okay, so what is wired glass and where do we use wired glass?
So we briefly spoke about wired glass when we talked about safety glass. So wired glass, at least in the United States, back in the 70s, it was considered a fire-rated safety glass. They've since changed some codes and requirements where it still has a safety designation, but it's not as commonly used for fire-rated applications because just the technology has changed and there's much better fire-rated glazings now. But we spoke about before that wired glass is actually a piece of float glass that has wires built into it when it was actually created and molded together as glass. Again, I most commonly see this here in the city used in stairwells and fire stairwells because it still has a fire rating to it, although there's better glasses now that you can use rather than wire glass. And sometimes people don't want to see the wire there because you're literally seeing a grid pattern inside a piece of glass. And it's like, okay, you're taking away the view now. But in the stairway, it's enough to let you see what's on the other side of the door. So God forbid there's a fire, you can see if there's smoke or if there's anything going on the other side. But it also has a rating to it. So I believe it's like a 25-minute rating that 1/4 inch or 6 millimeter wire glass has here in New York City. It's generally used for a safety application like that, where you have a potential for a fire and you want to have some semblance of safety or a time frame to allow people to exit, and it's not going to be the vulnerable point. Generally, safety wire glass would be going into a fire-rated door. So the whole assembly between the door frame, and the wall that it's inserted into all has a fire rating to it. And again, the glass, you want to make sure that the glass in that door stands up to the same criteria that the rest of the assembly does, because you don't want that to be the weakest point.
Yes, so radioing is so common.
It's not, I saw a lot of it in the 80s and 90s. I'm going to say now I'm not seeing as much use of it because, like I say, they have come up with different options. Again, more expensive options, but again, you're getting rid of the wire and it's going to be a little bit more aesthetically pleasing to not have the wire inside the glass.
Okay, so when I'm walking on the block, I'm not looking at the wired glass.
Yeah, I mean, you're not going to see it. I'm going to say I rarely see it on an exterior application. I've only seen it maybe once or twice in my past 30 years on an exterior application. Usually it's an interior application for a door or maybe a manager's office that's overlooking a factory or something like that, because it's a cheaper version of glass and it has a rating to it. Although it's a slight rating, it has something to it that's you're able to do.
It's an old version. Okay.
Yes.
So
newer and better now.
So I'm asking my last question. What decisions parameters affect the choice of glass on the facade system?
All right, so we talked about a lot of different types of glass today in today's episode. The types of glass that will go into a facade system is, I guess the number one criteria is we're seeing a lot of the buildings now, and we're going to talk about commercial buildings, and same would be true for residential housing, is that you're going to want to have a performance to your glass, because who wants to pay high energy bills? A building owner who has a multi-story building has a much higher, and even us as homeowners, we're not going to want to, we want to try to limit the amount of energy purchases that we have to make to fuel our house. So by having an insulated unit is much better than just having a single pane piece of glass in your window. So I know that's one of the easiest options that homeowners do when they move into a house. If they have the old single pane windows, they'll go to an insulated glass window system, because it's going to more than double your performance. Now, again, we talked about having just the airspace in there. So if you want to spend a couple dollars more, you upgrade to the argon gas that's in there, because that's going to be even a better blockage of losing your heat from inside your house if you're heating up to the outside colder air. And then we can go on to your tinted glass with the low E. So again, so if we could stop, the heat from again, leaving the inside of the house, the outside of the house by having an additional coating on the inside face of the glass, plus the argon gas, you've now like doubled the performance that the argon gas gave to you. So you're now making a piece of glass that's almost 4 times as efficient as it was. So the architects and designers will come up with their design saying, hey, we need to meet a specific energy requirement. A lot of towns and cities have requirements now of minimum requirements of what, how much heat loss can come out of a building. We're seeing more and more buildings now that are just full glass facades. You know, you used to have like brick with a window, brick with a window, brick with a window. Now you're seeing full faces of glass upside the building from the ground floor all the way up to the top of the building. So now that's going to obviously be very challenging to meet codes. So with that, that's where the architects get into a lot of these multiple glass, maybe triple pane glass to get better performance. They're going to see a very high coating of low E on it. And now in your larger cities, I'm sure you've walked down the block, in a larger city, and you see a building that has a blue facade and a mirror facade. You might see a green facade. You may see a brown or a bronze facade, and then you see standard windows that are clear that you can see through. So all of these coatings, like when you do that reflective coating, that's there for a reason. When we talked about dissipating the sunlight from coming in, that's the type of coating that will stop the sun rays from coming into your building and blocking them out. So, but then again, it could also be an aesthetic issue. The architect wants to make his mark. Hey, that was my building. I designed. Hey, the blue building with the blue glass, that was my building. So it's also like, a little bit of a badge of honor, for a design team to say, yeah, I did the blue building down the block, or I did the green building down the block. So, so to answer your question, the type of glass is going to be on the local code requirements, what you have to meet for energy requirements. And then also the second part of that would be the aesthetic issue, is what the architects would like to see, how they want their building to be viewed by the general public walking by it.
Yeah, I like the buildings with the ones that they start with the glass on top of the glass. So you look at yourself as a mirror. Yes. I love them. Yes. So you can see yourself when you're walking and you're checking out, oh, my outfit is good. I look great.
I'm looking good today. Yeah, there you go.
But what I think is, like, we can clean the windows at our houses, but how do they clean when they like 80 floor, 90 floor? So it's so hard to clean it.
Part of what I promised you I was going to send you some pictures, and I'll get some pictures over to you. There's 2 different ways you can clean these glass on these high-rise buildings. We talked in a previous episode about the types of windows. We talked about casement windows that actually act as like a door. So we have limit stops on them, so they can only open so far, so nobody could fall out or throw anything out of a window. You're able to disengage that limit stop so the window opens up to 90 degrees, and you can actually reach out and
clean the window.
They actually have bolts on the windows that a man could put a strap around him, bolt on, so that way he becomes safe reaching out. So God forbid he doesn't have any issues falling out. But that's actually a requirement. So when you open the windows that far, a man has to be strapped off. So that's the easiest, cheapest way to do it. But then you're actually asking somebody to have a squeegee or a rag or something like that going out doing this, which is not very easy. The more expensive and more commonly used now is they have a scaffold system that's built on the roof that will come out, and then you have cables coming down with a platform and men on the platform. So I have pictures of that, because that's kind of what our company here in New York City does, is we clean windows like that. So I can put together some photos for you, so that way we can share them,
so exciting.
Podcast, so that way people can see what we're talking about. But in essence, basically, the rig will have maybe about a 20-foot basket, goes down, it comes back up, then you move it over, you do the next section. So basically it'll take maybe almost a week to clean a building, because you have to work your way all around the whole building to do it. And
it's like this.
The rig going up and down a building doesn't go that quick.
So it's like this, Rich. You started to clean on the 80th floor, okay? So when you started to come down, the rain starts, and so it's like, okay, so well done.
Start all over again the next day. Yes.
That's incredible.
Yep.
Okay, so Thank you very much, Rich. Today I learned a lot of things from you. I hope everybody learned a lot of things from you.
I hope so too. Yep.
I love your informations.
All right. So I look forward to our next cast, and I'll speak with everybody next week. How does that sound?
Yeah, that sounds great. I'm so excited about it. So see you next week.
All right. Good night.
Bye bye.